Hi guys, today is Unit 11, Day 1. So we're starting a new unit, and we're going to be talking about probability. So I'm going to go through these first couple notes pretty quickly. I have them already written out. So I'm going to talk through them. If you guys need to pause the video to copy down what I have in the notes, please feel free to do that, and then we'll dive into some example problems. So there's 4 different types of probability that we're going to be talking about today. We're going to use the uppercase P for permutation. For one of those, and that's when our order does not matter. Does matter. It's right there written, guys. So order does matter, and I'm going to kind of talk through all of these as we kind of dive more into our examples. So C is our combination, and order does not matter for combination. So make sure you're writing all of that down. And the next I have is the exclamation point. So that's going to represent what's called factorial. So the definition for this one's kind of tricky, so I wrote out an example for you guys. So 6 factorial, so if you were to put 6 and then that exclamation point, all that means is every multiple below it, whole number, you're going to multiply. So 6 times 5 times 4 times 3 times 2 times 1. So that's how factorial would work. So you're going to use your calculator on this. So I wrote out the directions for how to use it on the calculator, and I'm going to show you guys real quick as well. So if you have your calculator out in front of you, you're going to hit the math button, just like I have on the directions here. You're going to arrow over 3. I think there's just a little glare there. Let's see if I can get rid of that for you guys. You're going to arrow over and to the PRB, so that's probability, and there's a couple options for you. 2, 3, and 4 right there are the options that you guys would be using for solving these problems today. So the P, you can see that's number 2 for permutation, and then you have the C for combination, and then your exclamation point for your factorial on number 4. So we're going to dive into the last type of problem. It's called the counting principle right away. So we're going to start with one of those examples. So, number 1 says, at a restaurant, you have a choice of 8 different entrees, 2 salads, 12 drinks, and 6 desserts. So how many different dinners can be formed consisting one of each? So you have 4 different categories, so like 4 different selections for your meal here. So those are going to just be represented by boxes. So we're going to write out 4 boxes right here. And I'm going to label each one of those boxes just so I remember what was what. So I started with my entrees, and then my salads, onto my drinks, and then finally desserts. So in those boxes, all I'm going to do is put the number for how many options I have for each of those. So for my entrees, I have 8 choices, salads is 2, drinks is 12, and desserts are 6. All I'm going to do to get my solution here is multiply all of those together. So when I go ahead and put that into my calculator, I'll end up with 8 times 2 times 12 times 6. So I'll get a pretty good size number. So 1,152 different dinner options would be my answer. So that was the counting principle when I was just trying to look at how many different selections and categories I would have for my options there. So number 2 says, a make your own adventure story lets you choose 6 starting points, gives you 4 plot choices, and then has 5 possible endings. So this is almost exactly the same as the one above. We just have 3 options instead of 4. So we're going to do boxes for 3. So we started with our starting points, and then we have plot choices and endings. So I'm going to fill in those boxes. So I will have a 6, a 4, and a 5. So same thing as I did up top, I'm going to multiply those 3 together, and I'm going to get my total, which is 120 different adventure options. All right, so let's move on to number 3. 3 says a password for a site consists of 4 digits followed by 2 letters. The letters A and Z are not used, and each digit or letter may be used more than once. How many unique passwords are possible? So we're looking at the same kind of problem again. We're going to have a few different options for these, but we start with 4 digits and 2 letters. So we're going to make 6 boxes right here. All right, so our first 4 boxes consist of digits. So when you think of digits, those are single, only one number. So 0 through 9 are our digits. So we have 4 boxes of digits. So that means we have 10 different options. If we're saying 0 through 9 are our options, that's giving us 10 different digits to choose from. So we're going to use 10 digits. It says each digit or letter may be used more than once. So that means we will have 10 options each time. So we don't, if that means if we pull like a number 1 out the first time, the 1 goes back in for the second option. So you still have 0 through 9 for your choice. So those are our first 4. And then the last 2 are our letters. But these directions are a little bit different. It says letters A and Z are not used. So if we have 26 letters in our alphabet, and we're not using A or Z, that's going to be 26 minus 2. And the directions say the letters may be used more than once. So same thing again with our digits. If we have 24 letters the first time, if we pull out the letter A, we're going to put the letter A back in for our choices. So we still have 24 options. So we're going to take all these, multiply these together. It's going to give us a nice big number. So we are looking at 5,760,000 unique passwords for those options. All right, so let's jump down to number 4. I know I'm working through these quickly, but we're going to spend some more time in class going over these. And if you have questions, please feel free to stop the video, go back and rewind anything that I've said. Number 4 says, how many ways can a club select a president, vice president, secretary, and a treasurer from a group of 6 people? So we have 4 different positions. So we have president, vice president, secretary, and treasurer. So we're going to start with 4 boxes. So we're going to label all those boxes. So we have president, vice president, we have secretary, and we have treasurer. So if you have those 4 boxes and we have a group of 6 people to choose from, the way you need to think about this sort of problem is if you choose someone to be a president, then they cannot be the vice president as well. So you have all 6 people to choose from for your president. So you're going to put a 6 in that box. But if you choose a person for president, they're now out of the running for vice president. So you're going to drop 1 person for your option here. So we're going to drop down 1. So we're going to go from 6 to 5 for vice president. So now we have a president and a vice president chosen. So we're going to drop down 1 more for secretary. And we're going to do the same thing for treasurer. So we're going to have 6, 5, 4, and 3. And again, we're going to do the same thing with multiplication. And it's going to tell us right here, after we multiply all those, we have 360 different ways that we could select those 4 offices. So go ahead and flip to the next page. We're going to look at number 5 here. So let me make sure you guys can see that on the screen. There you go. So number 5 says, how many ways can a stylist arrange 5 of 8 vases from left to right in a store display? So if you're looking at this, you have, let's take a look here. So you have 5 of 8 vases from left to right. So we are going to label 5 vases. So I'm going to make 5 boxes. So it says, how many ways can we arrange those? So kind of similar to the problem that we just did, we're starting with all of our options. So we're starting with 8 vases from the beginning. So we have all 8 options for our first vase. But once we display a vase, that vase is no longer an option for the next slot. So we will drop down 1. So we're going to go from 8 to 7. Now you have 2 vases displayed, so you're going to drop down again to 6, down to 5, and then again down to 4. So again, very similar to all the ones that we've done up to this point. We're going to just multiply all of those numbers together, and we're going to end up with 6,720 ways to display those vases. Number 6 says, how many ways can 2-digit numbers be formed using only the digits 5 through 9 and by using each digit only once? So we have a 2-digit number, so that's how many boxes we're going to have because we are only holding the place for 2 digits. So we have our first digit and we have our second digit. Okay, so we have those 2 digits there, and we have only the digits 5 through 9. So 5, 6, 7, 8, and 9 are our only options. So that's only 4 digits, 5 digits. 5, 6, 7, 8, and 9. I have 5 options the first time, so I'm going to put 5 in my box. But I can only use each digit once. So if I use the 5 up the first time, that means I'll only have 6, 7, 8, and 9, so I'll be down to 4 digits the second time. So, again, all we're going to do is multiply those two together. 5 times 4, so that means we are going to have 20 different ways. All right. So 7 and 8 are a little bit different than what we've been doing. So 7 says there are 12 different colored cubes in a bag. How many ways can Katie draw a set of 4 cubes from the bag? So for this, we have a problem where the order does not matter. So if you look back at your notes earlier, if we have a problem where the order does not matter, that's going to be a combination. So this is going to be a combination problem. So we had our calculator out earlier, so we remember in order to get to combination, we are going to hit our math button, arrow over, and we're going to choose number 3. So that's what we should see when you're going to do this problem, is that. So I'm going to clear this because we're going to enter all the information from our problem right now. So we're going to start with our larger number. So we have 12 different colored cubes in a bag. So we're going to start with 12, and it says, how many ways can Katie draw a set of 4 cubes? So right now we have a set of 4 cubes from the bag. So we're just going to type into our calculator 12C4. So we're going to put our 12 in. We're going to arrow over to probability down to our NCR right there, number 3 on that menu. So we have 12, and then we're going to put in our 4. So we end up with 495 different options. So we have 495 different combinations there. And let's look at 8 as well. So it says the swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many ways can the swimmers be selected? So I have 8 swimmers. So that's I'm going to start with my larger number. That's my total pool. I have 8 swimmers. Pool, no pun intended. Ha, ha, ha. All right, so 8 swimmers is how many I'm starting with. And then it says 2 swimmers will be selected to swim first. So again, the order doesn't matter. It doesn't matter which 2 swimmers I'm selecting. So I'm going to use my C, and then I'm going to put the number 2. So I'm going to start with my larger number, and then put my smaller number in. So I'm going to do the same thing again on my calculator. I'm going to do 8. And my 2. So I end up with 28 different ways. So 28 different ways our swimmers could be selected in. All right. So 9 through 13, I just want you to practice putting those all in your calculator. So pause the video right now. Go ahead and just fill in those on your own, and then start the video back up again and check your answers with me. Again, just like the example problem I just did, you're just going to plug them in. So go ahead and pause, and then when you turn the video back on, all of the answers will be filled out.